Y'all good? How's your weeks?
Fantastic.
Fantastic.
How
Great.
is Ziggle?
Ziggle's good.
All right. I think we can get started now. So,
Yeah.
welcome back to Nick's Algebraics. With me today, I have a random guy.
You know me. I know you.
Yes. And a random guy is currently eating sushi right now as we speak. Just letting you know. So
I cannot verify that factually.
he is.
We
Indubitably.
Indubitably, yes. And we also have Greasehole, aka Peanut Butter Brother.
Wagwan fam, yo, like, I'm not gonna lie, yo, the Kiatis in Scarborough fam, like, they're actually mud fam. Like, you need to go out there fam. Like, they're literally cheesing fam. Like, the Kiatis are mud.
Brain rot is real.
It's
The British brain rot is real.
it's Torontoanese. I speak multiple languages. I'm quadrilingual.
Wow. How multicultural of you.
Thank you, thank you. I try.
And last but not least, we have Ziggle. All right. So, as usual, the guided notes, the blank one and the filled out one will be in the description. So, let's start off with example one. So, example one says, find the volume of the solid obtained by rotating the region bounded by the curves y equals cosine of x squared, y equals 0, and x equals 0 about the y-axis.
Hold on a minute. Aren't you going to like give us 3 pages of notes explaining the topic and then do an hour graphing it before we start the first example?
Well, you're gonna see what's gonna happen. I'm not gonna.
So
See.
impatient.
We're gonna get the plot 3D count plot 3D tutorial
yes.
every video.
Yes,
Yeah,
we're gonna.
Hope not.
I'm gonna use some kind of software in this video. Let's just say that.
This random dude is Scar. He's getting tutorial.
He is not. I think he's just a little cranky because he hasn't had his chow mein. Yeah.
He's morning dose.
This is prejudice.
No, it's not, random guy. You're just a random guy. You have no rights.
Yo, that doesn't make it better.
Anyway, we're talking about shell methods.
Yes.
Indeed.
Yes, indubitably. So, what's the first thing we should do for these volume type problems?
Draw
Graph.
Graph.
Yeah. So, let's graph y equals cosine of x squared. And we're only graphing in the first quadrant because it's bounded by x equals 0, which is the y-axis, and y equals 0, which is the x-axis. We're only looking at the first quadrant. So let's look at the y-intercept. How do you find the y-intercept of the graph of this function?
Plug in 0.
Yeah, plug in 0 for x. Exactly. So when x is 0, you have cosine of 0 squared, which is cosine of 0, which equals what?
1.
Yes.
1. Yep.
Absolutely.
Yeah. I just lagged. I saw it later than him, but I was thinking of it.
Of course, of course. So this is our y-intercept. What about the x-intercept?
We're going to have to set
we did.
y equal to 0.
Yes, set y equal to 0.
That's right.
No, I was just testing that to make sure you knew.
All right.
I think
Yes.
we should take the inverse cosine now.
Yeah, we can do that. I was just going to say cosine of what gives you 0.
Oh, if you want to be all unrigorous about it. I mean, I guess you're avoiding a domain restriction.
Yeah.
But, well,
You could.
I over
Couldn't
2.
you-
What were you saying, Ziggle?
I was gonna talk about. You can. I forget the name of the rule, but transferring it into arccos to isolate x.
Yeah, I was going to say the same thing, but Mr. Algebraics was all like, oh, no, let's just ask cosine of what equals 0.
Yeah.
And then we did it this way. So I agree with you, Ziggle.
It's your video.
I mean, you know what? Both ways are valid, fellas. But
You show every step and everything except limits, but this time you're going to skip a step.
yes, I'm going to skip a step. I know that cosine of pi over 2 is 0. So that means x squared right there has to equal pi over 2. All right. So if you take the square root of both sides, you get that x is the square root of pi over 2. And we're not putting plus or minus because we're just in the first quadrant. So x is positive.
That is a lovely intercept.
Yeah, very, very lovely x.
It'd be even more lovely to graph it.
Yeah.
Is it drawn to scale? Because I'm pretty sure the square root of pi over 2 is not equal to 2.
Well, the x-axis just has a different scale from the y-axis.
This is. Oh, I'm offended by that, but okay.
And so it's cosine, so just connect the two really like this. Yeah, something like that. And let me just do some shading. This is our region right here.
Hey, where's the music, dude? What are you doing? You buffoon, you utter fool.
There's a fire alarm in the building next to me.
Oh,
I hope they're not dying.
they are as we speak. Guaranteed.
I'm still standing.
Oh my God.
No copyrighted music.
Oh, yeah. So,
Copyrights.
No, it's fine so long as Nick identifies as a co-author.
yes.
Yes. No, that works. That does work.
Anyway, so we graph the region, so that's great. And again, we're revolving this region about the y-axis. Notice that the region is in direct contact with the axis of revolution, which is the y-axis. So that might make you think of using the disk method, right?
Mm.
Mm.
That's what I was thinking.
First thing I thought.
But what's the problem with that?
Um,
So
hmm.
the region is being revolved about the y-axis. That's a vertical axis of revolution. So when you have a vertical axis of revolution and you're using the disk method, that means the integral has to be with respect to y. So
I see.
yes,
I see.
which means we have to solve for x. We have to solve for x in terms of y. And when you solve for x in terms of y, you're going to end up with an expression involving inverse cosine.
I just realized the fire alarm is in my building and I need to get out and I'll be back within a minute.
Oh,
Well, you can't. You have to stay here. I'm telling you.
Okay, like I gotta go with the fire department. It's gonna, okay, so just I'll join back in a minute. Bye.
okay. Wow. Okay.
No, okay. That was interesting. Random.
Yes.
Very that was very characteristic of random guy.
Yes. Very random.
Well, he's probably dead now, so rest in peace, random guy.
R.I.P. random guy. So, as I was saying, when you solve for x in terms of y right here, you're going to end up with an expression involving inverse cosine. And that's very difficult to integrate. That's a Calc 2 integral.
Yeah.
So it would be better if we used another technique called the shell method. So the shell method is more convenient because it involves slicing the solid into cylindrical shells that are parallel to the axis of revolution. So since it's parallel to the axis of revolution, that means we don't have to solve for x. We can just leave it as is. But now that brings up the question, how do you find the volume of a shell? What is the formula for it? Let's do that right here. So this is the shell right here. And do you guys remember what the formula is for the volume of a cylinder?
I do.
Remember area of the base times the height?
Yeah.
So
The
what's the area of the base?
Area of the base is 2 pi r.
That's the circumference.
The
pi r squared.
pi r squared.
Yes, pi r squared. That's the area of the base, and then times the height.
That's what I meant to say.
Yes. That's the volume of a cylinder.
Yeah, like I was just, I had just like to recall it, like I knew it, but like it was on the tip of my tongue.
Of course.
Yeah.
So to find the volume of this cylindrical shell, you have to subtract the volume of the inner cylinder, which is the hole, from the volume of the outer cylinder. All right, let's do that. So volume of the shell equals, let me put some labels on here. Let's say that the radius of the outer cylinder is R2, and the radius of the inner cylinder, again, which is the hole, is R1. So what's the volume of that shaded yellow part?
So wouldn't that just be pi mega r squared minus pi mini r squared?
Pi r squared is for a circle. We're trying to find the volume of this shell.
Yeah, so it would be pi mega r squared times h minus pi mini r squared times h.
What's mega r squared? Aren't they both little r?
No, because it's the radius of the large cylinder versus the radius of the smaller cylinder.
Exactly. It's talking about
I'm just trying to write them different or differentiate.
Exactly.
Give it a little bit of that.
He's giving it a little bit of spice, you know. He's just, you know, spicing up a little bit.
That stochastic nature.
Exactly.
Of course, of course. So yeah, the volume of the outer cylinder right here, it's pi r2 squared times the height.
Just say mega R. It's like so much easier to follow.
You want big R and little r?
Yeah, mega R and little r.
You could call
Because like that's confusing. You've got r squared over 2. What even is that?
you could call R2, you could say
Just write capital R.
BRC, you could say BB. No.
Bro. Just write capital R. Just write capital R.
Well, there's going to be another R that's going to pop up. That's the thing. These aren't the only two R's. So that's why I'm using 1 and 2. You're going to see later there's going to be another R.
So then just write a large R, capital R, lowercase r, and then a cursive R.
Cursive?
Just put BWC for the small one.
You know what?
Pretty sure it's R. Just put a cursive R.
Put a random guy for the first one and then put a BB.
I think I'll stick with this convention. You'll see. I think it's great. But this is the volume of the outer cylinder, and then we're going to subtract the volume of the inner cylinder, which is the hole. So minus pi r1 squared h.
I'm telling you, it looks like chemistry.
Well, I love chemistry. Anyway, notice how both of these have a pi and an h. So I
Yes.
can factor that out and write it like this.
Why did you not write it pi h times?
Well, you'll see. I'm just going to keep it like this because I like it when h is at the end. I mean, you can put the h here if you want.
Everybody has their own flavor of autism. I get it.
Yeah, yeah, absolutely.
Random dude.
Oh, wonderful.
Random dude's back.
There was I don't know whether there was an actual fire or not, but I got back.
We had a debate, and actually, you could probably settle this for us. The debate was about Nick's confusing writing. I was saying that instead of writing pi multiplied by radius squared over 2 multiplied by height minus pi r 2 over 1h, we just write it as pi mega r versus pi mini r. And then if we need a third r, we write it as a cursive r.
You know, Ziggle over here was also saying like we could name the bigger one BBC.
No,
and then the
that
smaller
was all
one.
you. That was all you.
Smaller one.
That was all
BWC.
I prefer capital and lowercase as long as it's R's that we're working with. But if you add a third one, then we should resort to subscripts.
I think cursive r is superior, less confusing.
Reminds me of the real numbers.
Oh, yeah, that's true. I'm going to stick with the R1 and R2. So to find the volume of this shell, like I said, we have to find the volume of the inner cylinder and subtract it from the volume of the outer cylinder. So that's what I did right here. And I just factored out the pi h. And what do you notice about this? This is a difference of
Squares.
yeah. So
I win.
you get a gold star.
Yeah, I don't know. I heard my voice. Maybe there's a connection delay.
Nah, there's no connection delay. It was just I think you're just, you know.
I think you're still trying to figure out if that's the fire alarm that you're hearing
or just like the poison, someone poisoned your kimbap and it's just like
Right.
slowly seeping into your cranial cavities. You're just like slowly dying.
I have not had kimbap recently, but now that you mention it, I do want some.
He's lying, guys. He's lying. Okay.
Anyway, it's a difference of squares, and you factor that.
In factored form, it's R2 plus R1 times R2 minus R1.
Yes.
So A plus B times A minus B. Yes, R2. I'm going to do something kind of slick now. I'm going to multiply and divide by 2. So that will become 2 pi.
How cheeky.
Yes, and then I'm going to divide R2 plus R1 by 2.
Interesting.
Yes.
That looks like the average of the two radii.
Yes. R
Indeed.
plus R2 divided by 2 is just the average of the two radii. So it's the average radius of this shell. So that's this right here. The average radius would be to like the middle right there. We'll call that R. So this becomes 2 pi. And again, this right here is the average radius. So that's just R. And this right here R2 minus R1, that's delta R.
Could you possibly change the color for the colorblind audience?
Oh, sure. Let's see. How about purple?
Yes. We love an inclusive host. That's what we strive for.
I
We
try.
don't see color here. We don't see color.
Exactly.
So you get 2 pi r times h times delta r. I just switched these two. Okay, so that's the volume of a shell. It's just 2 pi times the average radius times the height times the difference between the outer radius and the inner radius, which is delta r. Like I said, this is the formula for the volume of a cylindrical shell, and it can be remembered as circumference times height times thickness, right? 2 pi r is the circumference, h is the height, and delta r is really just the thickness of this cylindrical shell. So that's an easier way of thinking about it.
I don't know why, but I for some reason I remember the formula looking different.
Yeah.
I must be. I don't know. Maybe I forgot about it. But I definitely remember what you were saying about like height times thickness times whatever.
This looks exactly like I remember it.
No, it doesn't. Be quiet, random guy. Your opinion is invalid. Anyway, yes, circum times height times thick.
Yes. This is the volume of one shell, but to find the total volume of a solid, we need to sum up the volumes of a bunch of cylindrical shells. And as the number of shells approaches infinity, this delta R, the thickness, is going to become
DR?
well, dx.
Yes, yes.
Serious right now?
Yes.
Explanation.
And this will lead us to this integral. V equals 2 pi times the integral from x1 to x2 of the radius function times the height function dx. So that's what this is going to become when you let the number of shells approach infinity.
I do remember this. Yes.
Fantastic. So this technique is called the shell method. Very nice name to call it, right? That makes sense because it's cylindrical shells. And this method is most effective when the disk and washer methods require integration with respect to a variable that results in a difficult integral. So that's what's happening right here. If I use the disk method, I would have an integral involving inverse cosine, which is not very fun to integrate. All right, so now we don't have to do that. I think it's time to go to GeoGebra right now and show you.
Yes, let's go.
This is what we're revolving about the y-axis, so keep that in mind. So it's going to look like this.
GeoGebra.
Yeah.
GeoGebra.
So this is one shell, and you can see as the number of shells approaches infinity, you get closer and closer to the volume of that solid. Isn't that wonderful?
That's amazing.
Okay.
Oh, I can't believe that. That makes sense, lad.
Fantastic. So I said this a little earlier, but when you're using the shell method, the rectangular slices are parallel to the axis of revolution. But in the disk and washer methods, they were perpendicular to the axis of revolution. So now it's reversed for the shell method. So if you have a horizontal axis of revolution, everything is in terms of y now. And when you have a vertical axis of revolution, everything is in terms of x for the integral. So we have a vertical axis of revolution. So our integral is going to be with respect to x. We're going to use this formula right here. All right. What is r of x? What's the radius function? What's the radius of each shell in general? Any ideas? Think of these shells, all these shells coming out of here.
I have an idea. Could I hypothesize that it is cosine of x squared?
But you're wrong, friend guys. So how about that?
That would be the height, not the radius.
Yes. My bad.
You before
I was gonna say.
I mean, it's commutative. R of x, h of x. Who cares what we call what?
Yeah. So we're talking radius like these distances right here.
Distances, random guy. Come on.
So what's
I
the
think
distance?
answer, since he thought it was so obvious.
Oh, it's not too hard. So what's the distance from the y-axis to this function right here? What's that distance?
It is, dude, simple. It's square root pi over 2.
It's
Simple.
x.
That's what I said. That's what I said. That's what I'm saying.
What are the bounds of this integral? From what to what?
So
0 and square root of pi over 2.
I would agree.
Yes,
Isn't he?
0 to the square root of pi over 2.
0. It's 0 to the square root of pi over 2.
That's right.
That's not your traditional accent.
Are you making fun of me now?
Yes, I am.
Are you appropriating me?
You dirty, filthy ziggle.
Oh, you
Get out of this country, fam.
a different culture now?
Yes, I am, because I hate all of them.
You hate
I'm
Ireland?
just kidding, I don't.
You hate Ireland?
Guys, viewers, listen.
Cancel this, man.
Listen,
I can't believe you
viewers,
said this. This is
viewers, that was purely a joke. It was not true. I love everybody.
Anyway,
Anyway,
back.
X% of x squared. I can't say it enough
Yes,
times.
the radius is x. It's just the distance from the y-axis. And the height is just x-axis to cosine of x squared is cosine of x squared. So we have x times cosine of x squared dx. We have to do a u substitution. So what does u equal?
Well, we never made a video on U substitution on this channel, at least not as of this one, but U equals x squared is a good
Squared.
place.
Is that not what I just said? Or
yeah,
you
Zego had it first. He wins this. Sorry, Random guy. He won.
Okay, fine. I'll give it to you. I'll give it to you.
Well,
That's appropriation. That's insane.
how about let's let Ziggle tell us what du equals.
Ziggle.
du equals x dx.
Close.
Wait. I've forgotten how to integrate it. Or differentiate.
Well, what's the derivative of x squared?
X?
Well,
Or 2x. 2x.
yes.
2x dx.
2x. Yes.
A little brain part there.
Whoops, my bad. Wait, hold on. Let's divide 2 to both sides. So we've got 1/2 du x dx.
Okay.
Yes. Fantastic idea. I love that.
Now we can directly sub in, replace x dx with 1/2 du.
Exactly.
Yeah.
So this would be no. Don't write the 2 again.
Okay. I'll just write the.
Oh, bro, skipping steps.
Yeah. One other thing is when you do a u substitution, you also have to update the bounds of the integral.
Yeah.
Get ahead of yourself. Dude, we do that last.
Golly gee.
Golly gee, random guy.
Golly gee willikers, you've got me fumbled here.
Absolute utter fool.
Okay, so it'll be pi integral. I think we should plug in the bounds afterward, but that's just me.
How about we write it as u of x1 and u of x2?
Works for me, I guess.
That's a great way to do it, in my opinion.
So when x is 0, u is 0. So that stays the same. And when x is the square root of pi over 2 and you square that, the square root goes away. So it just becomes pi over 2 in the top. That's great. No square root. And this x dx right here, that just equals du over 2. And that will cancel out with the 2 here like that. So you're just going to end up with a pi here. And this will become du because the over 2 is gone now. And the x squared is u. So you're just left with cosine of u.
Easy
So
money.
what's the integral of cosine?
The integral of cosine is
Sine.
Yes. So this is pi times sine of u.
Yes.
I'm gonna sign you.
Stop.
I'm shaking in my boots right now.
I'm shivering in my timbers.
Shaking in your boots.
Yes. So we got to plug in pi over 2, plug in 0, and subtract. So when you plug in pi over 2 for u, what's sine of pi over 2?
1
Yes. And then sine of 0?
is 0.
Yeah. So we have pi times 1 minus 0. So it's just pi.
Are you QEDing pi with that box?
I'm boxing it.
Oh my god, guys, pay-per-view. Nick is boxing pi. This is gonna be insane.
My gosh.
Event of the year. Oh my goodness.
Literally, we're gonna have Joe Rogan and Dana White all like both commentating. It's gonna be absolutely
It's
fantastic.
gonna be
Get your tickets now.
biggest event of the year. Get
Yes.
your tickets
Logan
now.
Paul and Jake Paul are gonna headline. the
If
fight.
we make unboxing content on this channel, I am quitting the channel.
You're quitting. We'll unbox some sushi for you. Like, you can have a nice meal and some ramen too. A nice
These videos are so racial.
It's not. You're just making it like
No,
that.
we're just
no one
being
front of
diverse,
race.
and
We're appreciating
with
culture.
different
That's we were talking about like watermelon stuff and the Kool-Aid in the other video.
Dude, didn't you
Okay, I do like the food you're mentioning though, so I'll let it slide.
One time I did.
I am a walking stereotype, so we'll take it.
Yeah, I don't know. Is he
I wouldn't say so.
like
When it
half,
comes to
What?
food, I know.
like a
Nah.
half stereotype, like a half stereotype? You know?
What are we talking about again?
I don't know. All I did is box pie and then it turned into this. Well, this is it for the problem. So notice how this integral is way better than if we took the integral of inverse cosine. That would have been way longer if we used the disk method and we had to do that integral. So the shell method really saved us a lot of time and pain.
Shivering in my timbers.
Indeed.
Absolutely. Okay, let's do example 2. Find the volume of the solid obtained by rotating the region bounded by y equals 2 minus x, y equals the square root of x, and y equals 0 about the x-axis. Let's start off by graphing these two functions. Let's start off with y equals 2 minus x. That's a good place to
Simply
start.
a line, fella.
Yes, that's just a line. And
-1 slope, start at 2.
yes, let me just put some numbers on my axes.
Axes or axie?
Axes.
Oh, so we're allowed to like number them now. We're not just assuming that they're different scales.
This time I'm gonna make them the same scale. So, yeah. And you're right. The y-intercept is 2 for the line, and it has a slope of -1. So down 1 over 1 and down 1 over 1. So like this. And square root of x, that goes through the origin, and square root of 1 is 1, so it's gonna look like this.
Kind of all we care about.
Yeah, that's all we care about because we want the region bounded by these two functions. And actually, we don't even really need this part right here. I can just use that part. And let me shade this region.
Hurry up, bro.
Dun, 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 dun. Good job.
I think you dare change the color.
No, he would never.
Oh.
No. Yes. Keep it green.
Keep your graphs consistent, otherwise it gets too confusing.
Of course, of course. And then we're rotating this region about the x-axis.
Yes.
Mixing it up.
Yup. What method do you think we should use, guys?
I'm gonna assume that because we're doing a video on sill shells, that we should do sill shells.
Yes.
Shell method. That's a good idea. What's wrong with the disk method? Because the region is touching the axis of revolution.
It's dissed me too many times.
Well, we have like two functions together.
Random guy's right. If we use the disk method, we would have to do 2 separate integrals, one for this function and one for this function because the radius is different.
Not that I have a problem with doing 2 separate integrals, but yeah.
But
I just like it when you say that I'm right. Say it again.
you're right, random guy.
Of course I am.
So the thing is with the disk method, since we have a horizontal axis of revolution, the integral would be with respect to x if we use the disk method. So we wouldn't have to solve for x. We can just leave it as is. So that is a plus point for disk. So for this one, it's up to you. You can use the shell method and do one integral, but it's going to be with respect to y. And it's going to be a pretty easy integral. Or you can do the disk method and do 2 separate integrals, but it's in terms of x. So you don't have to solve for x there. Since this is a shell method video, I'm going to stick with the shell method. So since we have a horizontal axis of revolution, and remember these shells are parallel to the axis of revolution, that means the integral is going to be with respect to y. So v equals 2 pi times the integral from y1 to y2 of r of y times h of y dy. Let's solve for x. So we have x in terms of y, since, again, this integral is with respect to y. So for y equals the square root of x, what does x equal?
Y to the second power,
That is absolutely right.
as usual.
And for y equals 2 minus x, if you want to solve for x, you got to add x to both sides.
Yes.
You subtract y from both sides, and you get x equals 2 minus y. All right, so all I did is I just solved for x, because, again, I want the integral with respect to y. So what is the radius function? What is r of y?
That appears to be the height of the graph.
That's what I was thinking.
That did appear to be the height of the graph.
I mean, it doesn't really matter what we call R and what we call H, since we're just multiplying two things together.
Yes, that's random guy. Don't be foolish. That's of the utmost importance.
We must understand.
Yes.
I understand the math when you can do the math. All you have to be able to do is do the math. You don't need to know the underlying reasoning behind the math. What are we, math majors?
Yeah.
Yes, you are.
That is a good point.
My point is, we don't have to understand the math. I don't care what's R or what's H. Just plug it in. You know?
Yes, we do. It's here. I'll put it in terms you can understand. It's like if, we made a California roll, right? And then we also made a rainbow roll, right?
Bro.
Those are two very different things. If we just call the rainbow roll the California roll and the California roll the rainbow roll, we're completely mixing up the two different sushis, and we're confusing the flavors.
Your analogy is not analogous.
Yes, it is. I know you understand it. Stop lying to me. You definitely get what I mean. But yeah. For the viewers at home, that's a good analogy to tell your friends.
Indubitably.
Indubitably.
So the radius function is just y. This distance right here from the x-axis is just y. And what's going to be the limits of integration? What's y1 and y2?
It is 0 and 1.
Yep, 0 to 1 right there. So this is the integral from 0 to 1. The radius function is just y. What's the height function? What's h of y?
H of y.
Yes. That's like a representative shell, kind of. I know it's not very...
It's a representative shell.
It is, indeed. Indubitably. It's actually pretty good.
Thank you.
You should switch to art major.
Maybe. Maybe I will.
You should just double major.
Maybe. But the height is just the distance between these two functions here. Those are going to be the heights of the...
We are going to subtract two functions.
Yep, we're going to do right minus left. We have to subtract. So this is 2 minus y, and we're subtracting y squared. All right. Yeah.
This is going to be a lovely quadratic looking thing. But then there's a y on the outside, so this is going to be all like cubic and stuff.
Yeah, it's going to be like a regular old integral. Nothing exciting. So
Yeah.
classic polynomial type integral. So distribute the y, and you get 2y minus y squared minus y cubed. What's the integral of 2y?
Y squared.
Well, yeah, y squared.
And what about for y squared? What's the integral of that?
That would be 1/3 y cubed.
Yeah.
Yes, indeed.
And for
1/4 y quarted.
yes, y to the power 4 divided by 4.
Quarted.
Like quadded.
Quarted.
I thought you like quadded.
No, that's
Sounds like
a
leg exercise.
quarted sounds better. But if you want to do 5, you can say quintic.
You could do that.
It's y squared, y cubed, and then y quartic, and then for y, and that's y to the power of 4, and y to the power of 5 would be y quintic.
Indeed.
I don't think this is official terminology, but I like it.
It's definitely not official terminology, but it needs to be because it's ridiculous.
True, I agree.
Time to plug in.
Yes.
It'll be really nice since the zeros we'll get rid of when we do that part. And 1 to any power. So just 1 minus 1/3 minus 1/4, and we're done with that.
Yeah, if you plug in 1, you just get 1 minus 1/3 minus 1/4. And like random guy said, when you plug in 0, this whole thing becomes 0, so we don't have to worry about that. So if you do the arithmetic, again, you guys are calculus students. I think you guys know how to do that. You will get 5 pi over 6. So 5 pi over 6 is the volume of the solid that's generated by revolving this region about the x-axis. All right, so any questions on the setup?
No questions, but it is a lovely unit circle value that we got for our answer.
Absolutely, yeah. All right, now for the last example. Find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0, about x equals 3.
It is graphing time.
Yes. So let's start with y equals 8. So I'm going to make the y-axis go in increments of 2, like this. And the x-axis will just go by 1. X cubed, we know if you plug in 0, you get 0. If you plug in 1, you get 1. And if you plug in 2, you get 8. So you get this. And this is y equals 8 right here. I'll just make it dashed. So let me shade the region.
Da-da-da, da-da-da, da-da-da.
Nice.
Fantastic. It says and x equals 8, which is the y-axis. So that's why it's this region here and not like this region. And we're revolving this about x equals 3. So x equals 3 is just a vertical line going through 3. So what method should we use?
I think, in my opinion, I don't know. This is a really tough one.
In my
go.
opinion, I would agree.
Yeah. I don't, dude. I'm gonna have to say this is by only a little bit though. I'm gonna have to say cylindrical cells, but I could be wrong. Easily, I could be wrong.
Because it could be washer method.
It could be.
Because it doesn't touch the origin.
The region does not touch the axis of revolution. So you could use the washer method, but
For the sake of the video.
But why is the shell method slightly better?
Because it matches the theme of the rest of the video.
Yes, that's
Because
true.
continuity.
What does continuity have to do with this?
He doesn't mean the mathematical continuity. He means like the story continuity.
I was like, oh, okay. So,
well, if you want a math explanation for continuity, I'll give you one. Because right now we've been on the same curve, going at the same speed, going at the same level. And if you want to differentiate and go on to some other topic, it would be creating a jump, which would mean that our constant line of travel would be not differentiable and therefore non-existent or difficult, and it would invalidate the validity of this entire video as a whole. And therefore, we want to stay continuous.
Preach, King.
Yeah, QED to that. Yeah.
So basically, shell method. Why don't you just tell us why it's better, in your opinion?
Okay. Notice how the axis of revolution is vertical. So if we use the washer method, the integral has to be with respect to y, which means I have to solve for x, and you'd get x equals the cube root of y. When you do integrals with cube root of y, you're going to have fractional exponents, and it's going to be kind of annoying. It's not going to be a tough integral. It's going to be an annoying integral. So if we use the shell method, when you have a vertical axis of revolution for the shell method, the integral is with respect to x, because again, the slices are parallel to the axis of revolution. So if the integral is with respect to x, you don't have to solve for x here. You can just leave it as y equals x cubed. And that will make the integral a little better. It'll be less annoying. You won't have like fractional exponents.
It's gonna be better.
Yep. So let's use the shell method. Again, vertical axis of revolution for the shell method means the integral is going to be with respect to x. So v equals 2 pi times the integral from x1 to x2 of r of x times h of x dx. So let's start with the easy part. What's x1 and x2?
X1 is 0.
Yes, 0. And what's x2?
Ziggle, what's X2? 2. Stop. Let him answer, you buffoon.
Sorry, there's delay, latency, whatever.
But random guy and Ziggle are right. The bounds of this integral is going to be from 0 to 2.
Yes. And also, Greasehole is right, too. AKA Peanut Butter Bro.
Absolutely. And
He goes many names.
think very carefully here, guys. What is the radius function?
Yes. Radius.
Is it 3 minus x?
Yes, that's right.
Yes, he stole my thunder, man. That's what I was gonna say.
I'm going to try my best to make this symmetrical.
The straightening line thing, which you do for the
Oh, not for the laser pointer. Yeah,
unlucky.
but here,
There's a premium subscription to Notability, I guess.
yeah, it's not fully premium. So this is a shell. This is just a representative shell, and the radius you can see is actually, let's look at this radius right here. You notice how if you look at this distance right here, it's 3 minus x, because this distance right here from the y-axis to the function, that's x. And this distance right here from the y-axis to 3 is just 3. And we want this distance, so that's just 3 minus x. All right, so that's the radius in general, is 3 minus x.
Makes sense.
And the height is going to be this right here. So
X cubed.
close, x cubed would be this. We want from
What?
x cubed to 8.
It cut me off. The latency.
Oh, so what is it then?
8 minus x cubed.
Yes, exactly. This is 8, and this right here is x cubed. And we want this right here, so you have to do the 8 minus the x cubed right here.
Yeah, it lagged. You gotta let me finish.
Yeah, silly me.
Wow, we got to be all inclusive here.
Yeah, no, come on, random guy.
Yeah.
Oh, no, we're gonna have to foil that.
Enigma.
Enigma.
Like to change the channel name.
You know, when I first started making like very basic arithmetic videos, I was gonna call the channel Nick's Arithmetics or something like that. But it
That sounds like Tourette's syndrome.
Yeah.
yeah, it does. So I decided I'll do
His Tourette's is activated, so sorry, he's making weird noises.
anyway, let's do this integral. So
Yeah.
we have to use the FOIL method. So first, 3 times 8.
I made a
I
video.
know this one. It's 24.
Yes, and then outer.
Negative x 3x cubed.
Yes. Yes.
Yeah, minus 3x cubed.
Okay.
And then inner.
Oh, you have an any?
Shut up. Minus 8x.
Yes.
X.
And then last.
Plus x to the 4th.
Yes.
Cortex.
Yay. No, I'm not saying that.
X cortex.
X Arctic.
Cortex
Quad. I like quadded better.
and quadded. X quadded. Okay, yeah, that's fair. That's fair. Random guy. X quadded.
Give credit to you. You invented that notation or that terminology.
X fourth ed.
But anyway, this is 24x.
Yes. Who wants to do the next term for the integral? Integral
3x
3x cubed.
is
3 4 6 quadded.
3 times x to the power 4 divided by 4. Yeah.
yes.
And then what about for 8x?
8x.
8x squared over 2.
So it's 4x squared.
Yes. And what about x to the power 4?
4
It's-
fifths x quintic.
Yes.
X to the power 5 divided by 5. Yes.
And no plus d. This is a definite integral. So we're gonna plug in that 2 and
Zero.
the 0. The 0 term will be nice and make everything go away. So just plug in 2 for everything.
Yes. So if you
I was thinking the same thing.
you guys are absolutely right. So if you plug in 2, that becomes 24 times 2, which is 48.
That's what I just said, dude.
Oh,
Enough.
oh, silly me. Okay, what about when you plug in 2 to this term?
Peanut butter brother.
When you plug in 2 to that one, then you get
Is it 12?
You get 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. And then times 3 is 48, which is 12.
Well, you're right. The easier way would have been 16 over 4 is just 4. So you're doing 3 times 4. And you get
Rui,
Is this an algebraic, calculaic, or arithmetic video?
Can we simplify the bottom to 36?
I think we should just skip to the final answer.
Yeah, let me. Okay. So
don't tell us what to do, random dude.
if you plug into 4x,
Minus 6.
yeah, minus 16, and then over here you have 2 to the power 5 is 32, so we have plus
32 fifths.
yeah.
32 fifths.
Wrong.
No, it's not wrong.
It's from.
There's a planned parentage. There's a planned parentage at my school.
Your school is full of waste, so I'm not gonna lie, bro. Like, I lied, yeah, like, yo, you're shot, fam. Like, it's over, fam.
No ID.
Yo, fam, calm down, fam. On score, bro. Yo, you continue, man. Continue, Nick.
Okay.
Yo,
Nick got his boxing gloves up. Nick's gonna box you.
no, he's not. He's a waste youth, fam. You're a good youth, fam. I'm not gonna lie, fam. Like,
because we're not skipping steps. Can you write -0?
You can.
Well,
no, we are skipping steps.
I'm definitely gonna skip the next step.
The plot.
Random guy's absolutely right, and Ziggle's absolutely right. When you plug in 0, all of this becomes 0, and you just you have a -0 at the end. And
it would be in the parentheses, yeah.
Yeah, if you do all the arithmetic, I'm not going to show it because there's.
Oh, thank goodness.
Yeah, this will become 264 pi divided by 5.
Wait, but then why did we give up on the arithmetic halfway? Why not? Why did we start the arithmetic if we weren't going to finish it?
Once you start stroking, you gotta finish.
That's not what I was going to say.
You can't. You gotta make it
valid.
You know.
That is very valid.
You gotta just.
It doesn't matter if you're
to the final spot. You gotta finish.
Smells her perfume.
Exactly. It doesn't matter what happens. You gotta finish, man.
Don't listen to him. He's a bad influence.
No, don't listen to random guys. The bad influence. He's the one always talking about kimbap and sushi and stuff.
Oh, those are bad things. I didn't realize.
Yes, they're not very healthy. They don't contain all the proper nutrients. You should have a balanced diet.
I was not a doctor, is he?
I am.
He's a doctor.
You didn't know that I went to Johns Hopkins for my MD. Like, come on now.
I've been to every college. He racked up so much.
Harvard, Yale, and also.
Yeah, I have degrees. Nick can vouch for me.
Yeah, I was in one of his classes.
Yeah, he was. He was. That's what I'm saying.
He was the student. He was the professor, actually.
Yeah. I was teaching a class at UCLA one time, and I was telling him about my background. So.
Yeah.
About how you worked on the Tesla Cybertrucks.
Yeah, I did do that too. One of the lead engineers. Nothing too crazy. Okay. Anyway,
you're friends with.
We didn't say which military.
So yeah, the answer here, guys, is 264 pi over 5, and we got that by doing all sorts of things. But make sure you remember these main formulas. All right, guys.
Yes, we have this table summarizing all the different methods. If you understand the table, then it won't feel like you're memorizing.
Understand the table, you understand all.
Yes, that's true. That is it for today. I think it would be best if Peanut Butter Brother, aka Grease Hole, close us out.
Yep. Okay, guys. Hey, it's been a great video. Okay. Make sure to remember all that we taught you. Okay. Make sure to use this cylindrical shell method to make things a little easier in your life. To make things a little easier when you get to that difficult question on the math test. And make sure you hit that subscribe button. Smash that like button. Ding, ding, ding. And turn on those post notifications. Set them to all so you never miss an upload. It's been your boy, Peanut Butter Brother, signing out. Make sure to check out all our new stuff. We got plenty of bangers coming out soon. And yeah, guys, have a great day. Do well on that math test.
All right. See you guys later. Bye.
Bye.